Cloud Native Live. I'm super excited today to dive into more of Falco. I'm joined with Nigel Douglas here. Just a reminder that this is a official CNCF live stream, so we have to abide by the code of conduct. So please be nice in the channel and the chats. Nigel, welcome. How are you today?
Very good. Yeah, no, it's the end of my day. I'm based here in Ireland. But yeah, super excited to be presenting
Nice.
to everyone today.
Yeah, I'm excited to talk to you. I've seen you a lot through the years in blogs that you've done. How long have you been in Cloud Native for?
Yeah, it's a good question. So I've been here with Sysdig about 2 years. Before that, I was actually working on Project Calico at Tigera. So that's a CNI network policy for Kubernetes.
Yeah.
I was doing that for another near 2 years. And then at very early before that, I was working with a company called SolarWinds, which no one would really think of as a vendor that has anything to do with cloud native. But as Datadog and Dynatrace and these vendors started getting into cloud native and said, hey, look, we know how to instrument Kubernetes and get some information about runtime activity, SolarWinds were like, we want to do that. And that was the point when I was like, okay, I just want to learn this Kubernetes stuff. And since then, that's been my whole life. So it's
Yeah,
quite an exciting journey. So I've been here about 5 and a bit years doing cloud native. So it's brilliant.
yeah. I just remember as my journey through Cloud Native as well, I remember getting some good takeaways from your blogs that you've done and seeing your name pop up a lot. So yeah, really nice to meet you here.
Yeah,
And
awesome.
will you be going to KubeCon soon?
Yes, so I'll be at KubeCon next week. I'll be representing
Okay.
Sysdig and Falco.
Mm.
So the exciting thing about that is we'll be doing an offsite activity for Falco, very close to the venue. So for those who are attending, who will also be in Salt Lake City, there's still
Yeah,
time to sign up for our live training. It's a free to attend. There'll be pizza, which is great fun, and we'll be talking about Falco and how to detect security threats. So yeah,
yeah.
looking forward to that. And also, yeah, we've posted that there into the live stream. So feel free to go to our events page. And if you're around just under KubeCon North America, there's the sign up link for the event.
Cool. And for those that haven't registered for KubeCon North America, it's not too late. We also have the link down here as well. So looking forward to seeing you folks there. So yeah, thanks, Nigel. So I'll let you start the presentation. Looking forward to watching it.
Yeah, no, absolutely. So I think, yeah, I'm sharing my screen and I'm on the events page. So as we mentioned there, if you want to sign up for upcoming events, you can do so. But right now we're going to focus on this activity, which is managing threat intelligence. I thought the safest thing to do was do this all from inside Instruct. So if I just do this and give you a full widescreen, it should be easy to read. But for those attending who don't know anything about Falco, we are now a CNCF graduate project, which is great as of this year. So we graduated, I think it was like a week or so before KubeCon in Europe. So, it feels like it was yesterday, but some time has passed. But it was a rigorous process to do this, and we're glad that we achieved it. Falco as a project, it observes runtime activity in Kubernetes and containers, and it achieves that by instrumenting the Linux kernel to pull, you know, system call activity via eBBF, or you can do it via kernel probe. But nowadays, most people are doing this via eBBF. We have plugin architecture to collect events from outside of the host system and containers. So we can look at your cloud provider, GitHub, Okta, anything that really has a real-time event stream. We can stream it through these arbitrary plugins that you can build yourself or use community-provided plugins. In today's session, what we're going to do, and I think it's fun, so hopefully everyone else will think the same, is we're going to use Atomic Red to generate real pen testing scenarios. So we're going to generate real event activity. It's not like bias events that I'm using. It's an open source project, and the link to that is in the chat about how we built an Atomic Red deployment manifest for Kubernetes so that you could test, any tool, but in this case, Falco. So we use Atomic Red. We're going to deploy it into Kubernetes environment. We're going to run those tests. We're going to check for coverage in Falco. And the exciting thing about checking for coverage is we're hoping Falco doesn't detect something. By not detecting something, then we can understand the adversarial techniques and defensive measures. So what are they trying to do? And can we build a detection rule to actually address it? So this is super exciting. Again, atomic red tests are built on the MITRE ATT&CK framework. So you'll see these numbers like T10532 or whatever it is. And these technique IDs, these are basically what is being performed, and they're industry vetted and recognized standards. Then we're going to use Falcoctl for managing rule set if we have time. And if we're really lucky, we may touch on Talon, but generally speaking, we'll leave that to a later session at CNCF Live, where we're going to talk around Falco Talon as a response engine for Falco. It's a very new component to the project. So I hope everyone can see my screen fine. If not, if there's any issue, I might just blow up the text in the terminal to make it a bit more readable. And again, you can let me know if any of this is hard to read. So the first thing we do is we check, well, what does our system look like? So I could check pods-a, and there's really nothing there. I have a snap local file, that's it. So I just have, core DNS and a metric server. If I check kubectl get nodes, -o wide, you can see I just have one single control plane node, and it's running containerd as the container runtime. So knowing it's containerd as my runtime, what I'm going to do is I'm going to install Falco. I'm going to use TTY set to true, so I want real-time activity, which is always exciting. We're going to use a modern eBPF probe as the method for collecting the events. We're going to use projects like Falco Sidekick as a way of, we're not going to use the UI component, or we're not even going to have local storage. That's fine. But basically, we're going to turn on Falco Sidekick as a way of handling, for instance, detection activity and feeding it to Falco Talon to take response actions. But then the collector option, we have a specific collector in this case for the containerd runtime. So hitting enter here, that's all we do, and we deploy Falco. Once deployed, what we do is we can use kubectl get pods to check for is the pod or is Falco in a running state. And for those who are familiar, we have to go through this process of initializing, then running. Currently, it's not of one running, but that's on Falco Sidekick. We'll give a few more seconds, and Falco is now running. You could wait the whole time for it to be 2 out of 2, but just to prove the point, if we were to, for instance, check logs for Falco, we can see it's actually running just fine. If it's 1 out of 1, we can double check again, but yeah, it's still 1 out of 1, 1 out of 2, but either way, we can see by checking the log output, right? So we're using -logs-l. So we're checking for anything with the label of Falco. Then we're saying, okay, in the namespace Falco, for the container Falco, give me a log output of it. And this logs command is actually how we're going to see detections. It sounds silly on first thought, but this is how it's going to work. So all we've loaded, you can see here from loading rules, is that we loaded the default rule set, Falco rules.yaml. Falco actually has a maturity matrix of different rules that are in different status. So there's stable default rules. Then there's also sandbox rules, incubation rules, deprecated rules that we're moving away from. So this is the maturity process. You need to go into incubation before you make your way to sandbox and then validate it in order to become stable and tested rules. So in our case, what we're going to do is we'll run a basic command here called find root name IDRSA. So what we're trying to do is find some credentials locally. When I do that, and then I quickly check the log output again, you can see that we get a detection. So that's what detections look like. There's default rules, like we mentioned, and one of these default rules is checking for instance, private keys or password activity found. Now, to the point about MITRE ATT&CK, all I did here was I used, for instance, grep, where I'm looking for things like keys, passwords, the TID for MITRE, and then also just MITRE to see if there's any specific MITRE activity. So in this case, we can see that I just ran this command, find root name IDRSA, by running that same log output and filtering it specifically for things like MITRE, key, password, and so on. I can see that it's tagged with the MITRE ATT&CK tactic and sub ID, tactic ID, but also we can see it's from the maturity stable rules, and we can see it's tagged with MITRE credential access. So we know someone was trying to access credentials, and we detected it. So, in a few seconds, we have Falco up and running, and we're detecting a real-world threat. Super exciting. So what we'll do is we'll check in this lab, and we'll move forward. And again, this should work the same in anyone's environment because these are the stable out-of-the-box rules. So yeah, I'm trying to do this in a sandbox environment to make sure, if anyone else wants to do this in the future, it'll work out the same for everyone. There was a link provided in chat a while ago, and it was, falco.org /blog/atomic red, I think, and that talked about how or the justification or why we built an atomic red deployment manifest. So in this case, we create a new network namespace and we'll call it atomic red. And then here's our deployment manifest. So we say kubectl apply. We're going to create a deployment. It's going to be called atomic red. It's in the new namespace called atomic red. It has a label. And here's the image, atomic red latest. It's actually one of my colleagues on the Falco project that's hosting this image locally. So now that we've created it, we can check for, is the atomic red tool running? Again, we have to go through this process of checking container creating. Then it should be running, and then we'll check till it's fully running, and then we can start using it. We don't want to move too fast here. It might just take a little bit longer to run. Atomic Red is a tool that was never really optimized for Kubernetes. However, we can get it running in Kubernetes. When I say not optimized for Kubernetes, it looks a bit strange on first experience. It's like a PowerShell tool, which we're going to need to exec into the Atomic Red pod and then run PowerShell, which will seem a bit weird in a second. But right now, it's fully running. So what I'm going to do is just check, and we can see, look, atomic red deployed, fine. We are good to move forward with this lab. We'll give it a few seconds, and it's all ready. You can see we can start and move forward. So what I did is I used tmux to basically create, it's like a terminal multiplexer. Basically, I have two terminals in the same terminal window view. So I'm going to move this a little bit here to the right because you don't really need to read all of this content over here. But I want to make sure this is visible to everyone. So what we've done is we've exec'd into the pod atomic red, right? And then we've run bash. So we can see we're root at atomic red. We're inside that atomic red workload. On the other terminal, I'm still in my same environment, but what I'm doing is I'm running kubectl logs again. I'm tailing, basically checking for real time anything from the container Falco, right, where bulk data is being deleted. Now, understanding, well, what is it we're trying to focus on? So understanding the MITRE attack technique T1070 with subtactic 004. Basically, it's file deletion on bulk deletion. So to my point about this not being designed for Kubernetes, you can see I've shelled into a Linux workload just to run PowerShell. And that looks really weird. Now I'm running as root with PowerShell inside a Linux workload. So in this case, what I'm going to do is I'm going to import all the atomic tests. So you can see import module. I went in import from atomic red team, invoke atomic red team, invoke atomic red team with the PSD1 file. And then we're going to forcefully import those tests. Do that a few seconds, and now I have the atomic tests. If I want to understand what those atomic tests do, I can pick, for instance, T1070 with the subtactic 004 for bulk deletion, and I'm using a flag get prerequisites. So using that feature flag, we can understand what are the prerequisites for doing this. And it will tell me there are no prerequisites. This test, right, is going to delete a single file for Linux and macOS. It'll delete an entire folder for Linux, macOS. It will delete a file system on Linux, and it'll overwrite and delete a file with shred command. Now, in case you're worried, this isn't going to destroy your system. What Atomic Test does is it creates fake files, fake directories, and then it deletes them as part of a cleanup process. So that's great. If you're unsure and worried that that's not true, what you can do then, we check the prerequisites. Okay, that's not going to change. So I want to check if there's, am I just checking the same thing over and over again? Prerequisites. I guess we'll just run the test here. 4, and then, so running the test, you can see we get the detection, right? So running the test, you can see, look, it shreds a file in the temp directory called victim_shred.txt. It's a file that was effectively created for destruction. We could create a folder just for destroying it. But either way, we can go through it, can tell you, look, the test was executed. Was it successful in, I'm not getting any red lines. So everything's running as it should. So over here, we're checking for bulk data has been removed from disk. And this isn't the rule name. It's actually context from the description of the rule. And we'll talk to that in a second. I just really want everyone to understand in a second how these rules are curated and how we're used for detecting it. But in the conditions are how we detect the rule. Below that, the output is what you see as an end user. Now, a system call is super rich. So a system call gives us potentially everything, right? So we can look at what was the user login ID, what was the username, what was the command that was executed, what were their permissions when they performed that command, what was the network namespace they're in. So for us, we could alternatively remove this grep here. I could say something like, I think this will work, -e, and then I could say something like, okay, I guess it should work this way, but let's say if I say shred, I want to pipe for something like atomic red -red. Okay, maybe that won't work. Let's just try going for grep -atomic red, right? And run that again. Then we run our test, and basically you can see this was run from atomic red. So the output is showing us, for instance, the image repository that was running this malicious activity was coming from if atomic red. That was our container image. We can see it was in the Kubernetes namespace of atomic red because we know we deployed atomic red into that network namespace. Yeah, we can see a bunch of things here, right? We can see container ID at the time because, again, containers are ephemeral, they die, new IDs are generated. So it's important to be able to track what was the ID at the time, but also what's the pod name, right? The pod name is subject to change because it's got an algorithmically generated suffix. So understanding historically all of the surrounding context, you can enrich it, right? So you could, for instance, enrich metadata context from Kubernetes audit log activity as well as system call and really understand where in the environment is this happening? Like, what was the deployment manifest or config map that's responsible for this malicious activity? So we can take proper action. So this is a very simple example of we ran an atomic test, right? I've got it tailed. So if I just keep running the test over and over again, I'll just keep getting new detections with new timestamps. They are in milliseconds. So as soon as a system call is omitted, it's fed like a live stream through Falco, and we get to detection output. So that's really, really cool. So I'm going to move forward with the lab to a new atomic test scenario. Server exited. Okay, no idea why that happened, but it's fine. It should work just okay. So we'll click on start. And the next test scenario I want to check for is the test scenario T1611. Now, again, if you're ever unsure, I put in atomic test thingy here, which just gives you, for instance, the TID from the atomic test GitHub, right? Red Canary are the company that builds the atomic project. So you can understand what are the tests that are being performed, what commands are going to be executed, right? Like kubectl context kind atomic cluster, running a workload, performing a restart on an Alpine image. You can see transparently, because it's open source, you can understand what exactly was being performed. So we know that we can always check the reference doc to understand what tests are being performed. To our earlier point, like we can run PowerShell again. So I'm starting all over again, where basically I shell into the atomic workload, I PowerShell. Once we perform PowerShell, I can import the tests just in case they weren't already imported. That takes 1 second. Then I can understand what are the details of the test. This one looks a bit more complex than the last one. So this one's, for instance, performing an escape to host operation. Let me check if there's any specific prerequisites. It will run the atomic to host technique to check if, look, Docker was installed. It checks to see if it's deployed this container. Yeah, okay, verify Docker wasn't installed, but that's okay. Look, even if we don't have it run, basically with system call detections, even if we don't have the underlying components prerequisites met, when that operation is performed, the detection rule is still looking for the operation whether or not Docker exists. So let's say we want to perform the test. Oh yeah, actually, let's prove that. So if I ran the test and I remove this feature flag, do you see it ran the executed test, but nothing showed up here for network tool launched in container. And even if I wanted to remove the grep, right, it might be an issue with grep. I'm filtering for something that doesn't exist, and I hit enter. This would look for all activities. And if I run this, still nothing, proving I don't have a detection rule that's going to detect that cron job. So that means we need to improve our detection capabilities with Falco. So what I'm going to do is we can go to terminal 2. So in a different terminal, I just do vi and I create a new file called escape rule.yaml. In fact, the file name doesn't matter. You can call it whatever you want. So having created that new file name, what I can do is paste in this YAML content. I'm creating what is called a custom rule. Inside it, I'm actually defining a new file name. It's called miterrules.yaml. A little bit confusing by the way I wrote it, but that's okay. So in this case, I'm creating a rule, right, called launch suspicious network tool in a container. And what you're going to see in the output is the network tool launched in container, right, with some output context. Now, these outputs basically are stripped literals from the system call itself. So things like, username, user ID, login user ID, process name, the actual command that's being executed, where it's been run in terminal, container information. So like, again, I could put far more context in here, but this should be more than enough for a detection. Now for this detection to work, right, we're looking at description. Our rule name is just an arbitrary string. It's just the rule name. The description, again, is as arbitrary. So it's just some context, a description, literally a description of what it's doing. So detect network tools like netcap, nmap, TCP dump, that kind of stuff. So the condition is what's going to trigger detection. So in the condition, we have spawn process. That's in our stable rule set. So that's basically a process with spawned. And so we support Boolean logic. So and it's a container. Now, if there's any question about what these lists and macros are, you can go up here. We can go to our rule explorer for Falco. And for instance, if I was go to macro and type in container, right? You can see I have a macro here for container. I have one in sandbox rules. I have one in the stable rules. Yeah, in the stable rules, the one we want to focus on. That's what we're using. And what it'll do is show you how it's configured. So the condition is basically if the container ID is not equal to the value of host, it's a container. And then you can see which rules actually use this. But pretty much every container detection is going to use the condition, the macro for host. So rather than specifying it over and over again, we do it once. We create a clearly defined macro, call container, and then we can define in our detection rule. So here we have a spawn process, which we know what a spawn process is. If there's any confusion, we can always go back to our rule explorer rather than looking up container, right? I think I can remove that. I don't know why that's happening. If I go to Control F and I just remove this. Oh yeah, cool. And I just do spawn process. Okay, cool. And then we can do that again. So basically, spawn process is if an event type is an execve or exec vyat, and it's an event directory, then we know it's a spawn process. Again, it's going to be used pretty much in every rule. So this tool is really powerful for understanding what rules are enabled, what macros exist. You can understand what are the stable rules, what are the sandbox ones, how they tie back to certain plugins. So I'm going to go back to our tool. So we have a spawn process, it's a container, but we want to define network tools. Now that doesn't exist. So for a network tool procs, I define a new macro, and the macro defines basically a process in a list called a network tool binaries. And then the network tool binaries basically is literally what it says it is. It's a list of items or processes. So in this case, these binaries like NC, netcache, nmap, dig, TCP dump, tshark, whatever. It's just a vague list of things that I thought were important that are most likely going to be used for container escape activity. We also want to say, and it's not a user known network tool activity, and the user network known tool activities are basically never true. So in this case, a never true is also defined as event num. So what I'm saying is you can go so granular with this nesting logic for detection rules. Rather than defining a big long spew of system call context, you can reuse macros, reuse lists. You can define these macros with Boolean logic, say it has this and it is not equal to this. So anyway, we've created our new custom rule. I can save it. If we were to go back to here, basically, oh yeah, what I want to do is reload the rules. So I want to go back to terminal 2. I basically want to say Helm upgrade Falco reuse the values that we had earlier, but basically just plug in -f, the file for escape rules.yaml. And Helm tells me, great, yeah, you've upgraded Falco, right? Falco can upgrade, happy helming. So everything's good there. So what I want to do, just to prove that there's no confusion, I'm going to delete the Falco pod. There's only one pod on my single node cluster. And now that I've deleted it, what I want to do is just check kubectl get pods -n Falco. And we can see, okay, Falco's nearly running. It's initializing. If you want to wait or watch, you can use -w. But I'm pretty confident 1 of 2 running, it's good to go. So it's done the upgrade. Now, if we were to check again for, was there a network tool launched in a container? And we run that invoke test for T1611, which was for the escape to host. Brilliant. It worked, and that's so cool. It's running the escape to host technique. Let's see what it shows. So we know all this about the cron test. We could show details. We talked about that thing earlier, which was, instead of prereqs, I think it was show, details. Parameter cannot be processed because the parameter name show is ambiguous. Oh, no, I forgot to put details. So yeah, show details shows us like exactly what's being run, right? So things like, if netcat was going to be operationalized, it's going to restart this container. Basically, a load of networking tools are going to be run. So by defining that list of those tools and checking for when they're basically being run in the container process, then we know a network tool was executed within a container. But the output that I mentioned earlier, by plugging in all those different output sources, you can basically enrich it to say, okay, I can see the user was run as root because it was a root container that we see over here for Atomic Red. We know all our tests are still being run for namespace Atomic Red. The pod was called Atomic Red. In reality, if it was a real attacker, they're not using Atomic Red, but you could filter, your grep command to show all the times a specific thing was run out of it. We can see the rule name was launch suspicious networking tool and container, but it also pretty much matches the description we set on it with all that context. It's cool. We can see that it basically was netcat was run. Netcat was run with certain permissions. We can see, again, all the things we wanted to see here. So you can get really, really deep with context. And again, just to prove that this wasn't a once-off, you can run your test one more time and you get your new detection. So we're in a really good situation right now. We're in a state where we kind of understand how Falco detection rules work. We understand that there's a public-facing rule explorer, so we can better understand the macros list that are available with default rules and incubation rules and sandbox rules, as well as deprecated rules. And we understand there's different plugin architectures out there. But right now, we're only handling context from the system call, from the actual host itself. So before I move over, what we could do is we could run this test. As I mentioned, instead of just relying utterly on MITRE attack, I could grep for MITRE. Let's do something like that. And then I want to run something like we mentioned earlier. Let's say I exit this, or actually let's do it from within it. Let's say I run find root name IDRSA within the atomic test. And just like that, it worked, right? So we have a detection for the keys or password activity. I think we talked about this one earlier, where it's basically sniffing for SSH keys. You could try to run cat to basically read content in the etc shadow directory. And if we do that, we see we get a new detection, which is warning sensitive files open for reading by an untrusted program. Again, we're all surrounding context of that. I could try exiting this workload. Let's say if I do exit, and I need to exit twice actually to get out the Linux container. But if I tried running kubectl run on a thing called Nigel root, I'm running as an Alpine image. Basically, we want to create it and then run a command from it. If I hit enter on that, does it trigger detection? Oh, it does. Cool. So it's saying, look, log files were tampered with. That's probably not the detection I wanted. Look, a shell was spawned in a container with an attached terminal. So it's so cool, the different things you can detect with Falco. We could, let's say if we're trying to snoop on credentials locally on a system. You could grep for AWS secret access key, but basically anything with AWS key, those kind of things, secret in the name, you could build an arbitrary rule around file names or context, string context. So you could do some kind of file identity monitoring. And when you hit enter, you can see in this case, warning detected AWS credential search activity. And then you can see again, what were the commands that were executed? Where was it run? By whom? What was their permissions? You can get really granular with your story. And again, this is an example of MITRE credential access. So certainly you can build your own custom logic in Falco that can go really kind of to your own use case scenarios. Finally, if we want to do something like cat etcd shadow, I think we might have done something like that a while ago. But yeah, same thing again. We can look at, for instance, sensitive files opened for reading by an untrusted program. So these are just some of the fun tests we can do by running arbitrary commands, checking if detection rules work. But MITRE ATT&CK was supposed to kind of obfuscate, I guess, away from us building silly kind of once-off commands and really have an industry standard towards, hey, look, here's the potential attack chain. Here are the tactics and techniques, IDs that are related to like real world incidents. By using a tool that's open source and standardized across the industry, and we rely on MITRE ATT&CK framework, we understand that it's a standard, then we want to build our detection rules around that standard. Yeah, there's a bunch of different things I could run, but I don't think I'm just going to go through each of these scenarios. So let's move on next in the lab. I don't know, are there any questions coming through in today's session that, you know, around any of the content here, or does anyone want to ask a question about what's happening? If not, that's okay. It's fine to be quiet sometimes as well. So this time we're just going to look at, for instance, you know, kind of encoded scripts. I think is a really exciting use case. So let's say we talked about earlier where you're detecting something like I see a Python script that was run, or I'm seeing a specific command or code being run in this command line. But if you're using base64, it's encoded. So if it's encoded, it's very hard for us to know what exactly was run. So what we could do is check how the Atomic team do this. So we PowerShell again in, we import our tests. So in this case, we want to import an atomic test, all the test scenarios, and I want to check for these two logon or boot initialization scripts that are run in Python. So there's the RC common and the RC local scripts. So if I was to invoke this test, nothing works. So naturally, I'm not detecting this specific method. So we mentioned RC common and RC local, but basically what they're doing is they're running Python 3 in both cases. So they're running a command, but the command, whatever they're executing, as you can see here, is base64 encoded. Now, when they run the command, they decode it. So that's still run as a legitimate Python script, or it's read as a script. However, as us on the blue team, we don't know what they're doing. So this is quite a common technique. Someone wants to bypass security controls, so they encode and decode stuff that they're running in the cloud. So what we want to do is better understand what are those logon commands all about. So if I was to show details, you can see that it's not so complicated, right? For the RC local, you can see that this is still tying back to T1037 with a subtactic of 004. I don't know about the other one, but they're probably both on 004. Yeah, they both are the same subtactic ID. So in this case, they run the file name, right, from etc rc local. They want to obfuscate what they're doing, so they're running Python 3, and again, it's an encoded script, but they decode it when they're executing. So you can see it's base64 exec, and then as part of that, it's base64 decode. So we're unable to detect it. We can check the prerequisites in order to check it. But again, there's no real prerequisites. It's just an encoded token, but then it gets decoded so you can actually see whatever the Python script is, the .py file. So in our case, what we want to do is we want to build a test because right now we have no coverage for this. Oh yeah, this is just showing us again what it is that what's being run. So what I want to do is go to terminal 2. And I want to VI, create a new file, and we'll call it MITRE rules, just so it doesn't conflict with the other rule file we created. And in this case, I paste the context. This rule is base64 encoded Python script execution. The description is basically saying the rule detects base64 encoded Python scripts on the command line, like we're focusing on specifically command line activity. So the condition's the powerful part here. So we're basically saying if it's a spawn process, we know already that spawn process was defined in the default macro list, within the default rule set of Falco. Then we're saying and in here, we're nesting some context. So we're saying the process command line contains Python C, Python 3.c, or Python 2. Do you know the way there's different versions of Python? Most people are probably using Python 3 today, but either way, you've got the -c to run a command. So that's what we're looking for on the command line specifically. So if there's a command line that starts with any of that activity, so it contains that context, or and there has to be additional context. So the command line also has to contain something like echo or base64. And if it also contains something like import or base64 to code, basically they're the things we're looking for. We don't know anything about the base64 encoded token. What we're saying is if it includes something on those lines, then on the output, we want to show what it is, basically what was the base64 encoded string, as one of the many outputs here. And we want to tag it back to MITRE ATT&CK. So we're running atomic test T1037.004, and we want to tie it back to, I may have done this wrong, but we tied it back to TA005 for defense evasion, which makes sense. It is defense evasion, but it also ties back to correctly obfuscated files and information, which is T1027. So we know this is all coming from system call. This is actually from the system itself. So I'm happy to save this rule. It looks correctly formatted, and the priority is set to warning. This is warning us that someone's running command line arguments where they're trying to run a script, but it's base64 encoded. So I write and quit. If I go to my file directory and refresh, you can see the MITRE rules file contains the file we just created. So I can go back here. Oh, actually, before I do that, I want to do what we should always do, which is basically upgrade Falco. I don't think you have to delete it. We can just do this out of force of habit, which is basically delete the pod, check again, kubectl get pods-a, and we'll watch with -w. And we give it a few seconds, we're initializing, and now it's running. So Falco's running, doesn't take too long to reload it. So now, if I check again for Python scripts, and we run our test one last time, but we'll remove any feature flags, so we're actually running the test, it worked. And how cool is that, right? Like we have a bunch of different output contexts. We're looking for what is the parent relationship, parent-child process relationship. So we can see, for instance, in a process tree, we can see like level 1, 2, 3, even 4. We can look for what was the process command that was executed. We can see process ID of that. We can see what was the executed path. Again, what user was responsible for performing that action, what user login group were they in. We can really get a lot of deep forensics in this. So if I go back here, again, there's a lot to look at. But the main thing here is that we got a detection. We saw what the command line argument was. And more importantly, we can see that there was a decode operation. And here was the Python string that they were trying to, what they encoded. So when they ran the exec, they basically or executed the command that had the token. We have that as well as all their surrounding forensics to say, okay, this was the time they ran it. Who was the user that ran it? From where did they run it? Was it in a container? Was it somewhere else? Obviously, in our case, it's run within the atomic red container, but it could be run on a host itself. Yeah, again, I love if we can get any questions on this. I want to make sure that we're definitely aligning with industry problems, but to the point about, can someone go home and do this today? I wrote a lovely blog. I like to think it's a lovely blog, but it was basically on the process of why we did this, why we created this atomic test tool, how you can run it locally. And basically, it's a bunch of other scenarios for running the tests, understanding, do you get a detection, then validating, creating custom rules. I did other examples like modifying authentication process or masquerading, matching legitimate names or locations and detection rules. These are all things in the MITRE ATT&CK framework. And it's important that we can understand that we can perform these tests, but naturally, can we also build detection rules around that, like clearing command history, indicating removal on host, loadable kernel module, because it's eBPF, right? Or even if we didn't use eBPF, if we still stuck with the kernel modules, we are instrumenting the kernel. We are getting real-time system calls. So that's from the lowest level in the system, from the actual kernel. And knowing that if someone were trying to, for instance, load a Linux kernel module into the kernel, like injecting an eBPF probe, and it was for malicious intent, then we would detect that in Falco. And I think that's really powerful. You know, if everything was run in user space, we wouldn't have kernel level context. And that's it's a game changer there. I think we ran this example earlier about building a custom rule for boot initialization scripts. All of this we try to document. So really trying to show that MITRE ATT&CK, as it's evolving, that the team at Red Canary are going to keep. So MITRE ATT&CK's an open source project. Red Canary managed the open source project of Atomic Red that's built on this MITRE ATT&CK framework. So the detection system they're building, the threats they're building, these automated systems, these tests, simulations are tied to MITRE ATT&CK. And then with Falco, another open source technology, we can really go ahead and build rules for it. So I'll go back into the lab. I just want to make sure that people really get the idea that this is a tool that you have full control, full flexibility to really address industry specific problems. If we try to perform the test, I think we covered all this a while ago, so we should be good to move forward. One of the things I kind of want to close out on is just the nature of, we talked about the maturity matrix. So, you know, there's different rules from different sources. So, you know, if I just check my architecture here, I'm, oh yeah, x86. So in this case, what I'm going to do is, I'm going to use the AMD 64 installer for Falcoctl. So the Falco project, you might have seen earlier that we were managing rules and we're putting them into individual YAML files, and I was doing upgrade on those files. Like, that's grand if you're doing individual testing, but in time it's going to become cumbersome. You know, you're going to say, is this the way I have to manage Falco going forward? So we introduced Falcoctl as an official CLI tool for basically working with Falco and its ecosystem components. So there's different ecosystem components we talked about. Falco Sidekick. There's the plugins. We have different drivers for Falco. You know, now we introduce things like Falco Talon as response engine. In time, Falcoctl will be a dedicated CLI tool across all ecosystem components. But right now, the use case is specifically around like managing rule sets and plugins, you know? So let's say if I was to use Falcoctl and I wanted to create an index file, and I can just pull the one from the existing Falco security project where we have the default Falcoctl index file, you can do that, right? It takes a few seconds. If we wanted to understand what that is, you can see in here, you can, for instance, pull, audit plugins, CloudTrail plugin, or these are just the tags on them. But if we go down to the different plugins, I guess. Yeah, plug it. And you can say, for instance, GCP audit. There's other plugins around things like AWS CloudTrail. Again, if you want to turn on a plugin, we can manage this via the index file to say what it is we want to turn on and what are the associated rule files that we're managing for that. If I go back in here, of course, you can list that index file we just created. So we can see, okay, it's just a generic index file. It was added on the 5th of November, and naturally it was updated on the 5th of November. We just pulled it just now. And you can see where it was taken from the source, which was the Falco Security, the official GitHub project, and that's the index file for it. Now, if I was to create, like, let's say, I'll close that. If I was to create a local directory, and let's use Falcoctl in a way that we could install an artifact like a specific rule file from a different location, you can do that, right? So I'm going to install this rule file to the local directory. And just like that, it resolves any dependencies. It'll pull it from the remote location, and then you should have your rule file. Now, if you're doing that all on a local host, that's the way you would manage Falco rules, right? You would go, okay, now check the artifact, search for it. You can see I have it. If you want to update it, you can, for instance, follow. You can check for updates to that remote rule file. So as you're not, you know, if you're the goal is to manage the rules outside of Falco. You're not supposed to be like realistically in production. You won't be going into terminal and making changes to a local YAML file. and then reloading it constantly. Instead, you'll want to manage the rules in a local repository or registry, and then be able to interact with that artifact. So that's one of the options. We talk through this idea of pulling different rules from different locations. But when it comes to using Falcoctl via Helm to update your managed rule set, we can do it like this. So we mentioned if I say kubectl get pods -n Falco, right? So we have our Falco pods, Falco Sidekick already installed. If I wanted to upgrade Falco, then I'm just going to say in the existing namespace Falco, reuse all values that I currently have for that deployment. And in this case, I'm setting Falcoctl in a way that I want to install specific references, right? So I already have the default Falco rules. I want the incubation rules. I also want the sandbox rules. And then naturally, I want to follow for changes, right? Any updates to those repositories for incubation rules and sandbox rules. And then we want to install from those files, which they're literally located in a specific directory. So there's Falco rules.yaml, Falco incubation rules.yaml, and Falco sandbox rules.yaml. So when I hit enter here, now if I say kubectl get pods -a-w and watch for changes, we can see it'll terminate the old pod and it'll start creating a new version of Falco. But now I have that extended rule set from the life cycle or the maturity matrix. So in case there's any confusion here, if I was to go to Falco maturity matrix, I think I have it here. Yeah, maturity framework. You can see here that the project, this was really just part of when we were graduating from CNCF, is we want to show that the project's evolved. It's not just a bunch of junk rules all thrown into one file. We have actually segregated rules into a logic that makes sense. So the production ready, you could say, the default ones that are going to have far less false positives or noise are in the Falco rules.yaml. Incubation rules, the rules that are, they require some testing to see if they're working. They'll go into the incubation process to start their journey. Then we'll sandbox them in order to actually perform some real kind of testing to make sure they're valid to go into Falco rules. But the ones that, for instance, when we have a rule that's replaced another rule, then it will fall into deprecated rules. Generally speaking, not everyone's going to turn on deprecated rules, but there are going to be cases where you might want a specific rule from the deprecated rule set, and you can absolutely turn it on by choice. But the maturity levels, again, it's to show where the project's going, that we are constantly evolving the project based on community feedback to address really the industry feedback, that it needs to be more stable in production. And that's what we've done here. The project's also introduced a bunch of other components. So most recently, we donated Falco Talon, which was a kind of a standalone thing, into the Falco security project. So if we check Helm and search for the repository Falco security Falco Talon, you can see now under the Falco security project, Falco Talon is absolutely accessible via Helm. You can see it's there, and the description is that it reacts to events from Falco. So for any attendees here who aren't familiar with Falco Talon, and we will talk on this in a later session, we're going to talk about introduction Falco Talon to get people up and running with Falco Talon, and we'll have an on-demand webinar in December for that. It's not too far from now. But if you want to know more, we have the Falco Talon docs. I guess the best place to go. And from here, you can really understand what Falco Talon does. So how to connect it to Falco, the usage, what was the intention, but more importantly, the actions. So in Kubernetes, things like terminating workload gracefully, being able to labelize workloads based on a detection triggered in Falco, enforcing network policy, all of this is API driven. So for instance, Kubernetes is a bunch of just open APIs, abstractions that we're all familiar with. So you can just run kubectl label pod in a namespace and it will label it, right? That's all done via APIs. We're familiar with those abstractions. So in this case, when a rule is triggered, then you can have any one of these automation actions. You might want to enforce a Cilium network policy or Calico network policy, or you might want to outright delete a resource in Kubernetes. And then to understand what those resources that you can delete, anything like a namespace or a config map, a replica set or stateful set, you can do that as a response to Falco rules. So the Falco project, to the point, it's constantly evolving. We just want to get people excited about the capabilities here in the project, especially for those who aren't maybe familiar with some of the more recent changes to the project. So with that, I want to jump back into the lab. I know we've got probably like 10 minutes left on the session. So maybe it's best that I leave it open for kind of a Q&A if there's any open questions from attendees. And I'll be happy to answer those questions.
Yeah, we don't have any questions at the moment.
Okay, that's awesome. So yeah, what else did I want to cover today on the session? We went through building our own detection rules. We used atomic red to generate those tests. We now shown that like it's evolved to the point where we have the Falco Talon response engine. As for upcoming events, like we said, we'll have a dedicated session on Talon. We won't have enough time to go through it today on Talon. But for those who are attending in Salt Lake City next week, we'll have like 3.5 hours or so to talk about Falco hands-on. Bring your own laptop. We'll provide, like I showed there with Instructed in a kind of a sandboxed environment. We'll give you a link. You can go into the terminal. You'll have all the resources accessible there to really just understand Falco and solve kind of your kind of biggest pain points today with the project. What else is there changing with the project? Like, yeah, of course, we're always looking for feedback from the community on places to improve, right? Like projects like Talon, Falcoctl, we mentioned there, they're really all drivers from community feedback. So like, yeah, again, any opportunities for us to improve, we will. I'm trying to think, was there anything else that was worth pointing out? I guess that could be it for today's session. Obviously, all these resources I can share as well, or they're publicly available. So you can always go to the Atomic Red project. You can look at all of the atomic tests. Any one of these tests that we mentioned earlier, when you say run invoke atomic test, you can just punch in a tactic ID number and it will simulate the test. So there's so many tests to perform, and all of these atomic tests, they really tie back to this MITRE ATT&CK framework. And again, if there's any confusion about what MITRE ATT&CK is, the MITRE Ingenuity team, they built this really powerful framework called MITRE ATT&CK, right? And it shows you the tactics, so from reconnaissance, from early stage discovery, all the way through to impact, right? So when we think of impact, we think of things like data destruction, stealing sensitive data, hijacking workloads. That's the worst outcome in the end. Other things like exfiltration, of course, are those terrible outcomes like stealing sensitive data. But in order to do that, they need to discover, perform reconnaissance on your environment, then do some form of resource development, like basically weaponizing scripts so they can get initial access into your environment. And once they have access, right, then they'll perform execution of scripts again in the environment in order to perform persistence. They want to stay in your environment. They want to avoid detection. We talked about the Python script thing earlier, base64 encoding scripts so they don't get detected by traditional EDRs or SIMs or whatever that's looking for specific context. They want to get privilege escalation. They want to move outside of Kubernetes. They want to move to the cloud. So we want to be able to detect, for instance, attempts to escape to host like we performed earlier, T1611. So if there's ever something here and you're saying, okay, we don't have great coverage for credential access from password stores, so we don't have coverage for the boot logon initialization scripts or something on the lines of this, you can see for every technique, there are some sub-technique IDs. And that's just goes to show the breadth and depth of coverage of MITRE ATT&CK. But more importantly, all these sub-techniques have their own, like for instance, we're not focusing on Windows remote management here because we're talking about Linux, but we can also filter this for just like Linux activities. But like if we go here to like deploying container, you can see, okay, how these procedures tie back to like commonly used attacks and what are the mitigation strategies. Like we talked about Falco purely from a detection perspective today for auditing to understand that something's happening. We didn't even cover Falco Talon as a response engine to actually prevent those attacks from playing out. But then there's all sorts of other preventative measures. We talk about network segmentation. you might be using Talon to enforce Kubernetes network policy in a Kubernetes environment to limit what connections can be established from that workload. From a detection perspective, it's key, right? We need to tie back to what it is we're detecting, and then clarify this has a specific MITRE ATT&CK tactic ID, so that our security operations center can go, oh, we believe that someone's moving laterally in the environment, and we actually have some real context. It's not just a random detection saying someone ran a command, because we don't know what that command means. But if it's tied back to MITRE ATT&CK framework, then we have something we can take action on. But with that, I think I've provided all the context I can on MITRE ATT&CK. I hope today's session was useful for those who attended. But if there's anything else you want to add there.
Yeah, I think MITRE ATT&CK looks really interesting. I'd like to check that out later on, and really looking forward to see the Talon in the next webinar as well. Yeah, for those folks that I know that watching this, it's like quite a lot to take in. So I really recommend the labs. We recently went to a KCD Australia where there was a Falco workshop as well, and there was a lot of people that got a lot of key takeaways. So yeah, highly recommend the event. So again, the link here, if you want to go to the Falco events, you can see all the events coming up. And yeah, that was a great talk. Thank you very much. I certainly enjoyed it and really loved the Falco project, and glad to see how far it's going.
Yeah, no, glad, and thank you for enjoying it. And I'm happy that I was able to present. So that was great fun for me as well. Yeah.
All right, so we'll see you